we perceive the history as being a continuum, right? We didn't move to quantic history, right? Made of small pieces, if you want. And
Correct.
the risk of this is the risk of linear predictions. What I mentioned is the Moore's law. If you predict only linearly and you don't think Moore's law reduces every 2 years or so the size of or increases the power of your chips by a factor of 4 or more, then you miss one opportunity. You miss one piece of data that changes the whole model.
Yes. And if you like, I can comment on some use cases. I mean, where we seeing
Please.
some traction in example. So the big shift is from turning reporting into the decision intelligence. And it can sound like very big, but actually if you start integrating multiple so sustainability should never be just the work of this small sustainability team of 2, 3 people within a company. It should be integrated at our business because that's the way it should be. It's about gaining operational efficiencies, about making better investments, right? So it should go from what were our emissions last year again to what should we do next week given this data, right? In order to achieve efficiency
Absolutely.
specifically. And that changes completely the mindset, but how we embed that into business workflows is important. So there's some use cases. I was mentioning the case of the due diligence. So if you're done ESG due diligence for any type of deals, but let's say real estate or infrastructure or for private equity, you know the drill is typically 4 to 6 weeks. You shouldn't take longer because you want to be fast, and especially in real
Sure.
estate markets. There's a lot of data mining by manual, like analysts reviewing a lot of information, permits, environmental impact assessment, local records, right? Litigation, community sentiment on whether or not that will work if you're doing a new development. Now, AI agents, as I mentioned, can turn this work from a day or typically 48 hours to 72 hours if it's a really complex deal. And then can create municipal records, analyze public hearing transcripts, all of that information so it can give you an actual sense of whether or not these investments align or can actually represent a risk for you, right? So the deliverable is not just a general like narrative that you will put on your investment committee memo. It's a risk register that you can act on even before you sign. And if you sign and that you decide that this deal makes a sense despite those risks, you already have a good sense of where the risks are located. If you're, let's say, in a floodplain risk area, in order to manage it, right?
Yep.
Or you can know in advance that, hey, potentially this is going to be a stranded asset 10 years down the line, so I'll better avoid it. So that's number one. Number two is that in the industry, not only sustainability, this is across the industry, we're obsessed with dashboards. We want to have a visualization of what everything is happening in some key APIs that we can quickly interpret or like look at the screen and say, hey, this is how this is moving, right? And we think we're in control because we're doing that. The reality is that there's a lot of moving pieces, and sustainability is, represents complex systems that we're touching upon, like climate, nature, and other things. Even engineering systems that shouldn't be as complex. They are if you scale them. But we need to move from dashboards and playbook. AI doesn't need a dashboard. AI does. They're not like staring at the screen looking at those metrics. AI can go deep into those individual things, right? So one of the first things we need to do is when we're doing these dashboards, typically we're aiming for the silver bullet, right? We're looking at climate change as a CO2 metrics, but the reality is that climate change is more than that, and it touches nature. There's methane emissions, there are other factors that we can have AI help us analyze the complexity of those layers and the interdependencies. Humans, as we are the way that we are, of course, we aim for simplicity, which is good. It has helped us, but AI can help us untangle those deep complexities that actually have an impact, right? So one example of how it's been done is that operationally we can have an example of a retailer, which is the name I can disclose, but this is like these dollar like stores, like a $1 store. So they have 500 plus sites, right? Typically, I mean, they have large portfolios, as you know, but this one in particular have 500 sites that we're monitoring for HAVC and water usage. And in the old model, what they would have done, like, and literally like less than 2 years ago, they will get their utility bills. Their utility bills, they were like printed or just PDFs. So you'll have someone manually inputting the information on a system like Energy Star. And then after several months, seeing, okay, what's been the trend on the year, right? So only that's a way they would see if something was off, but that was already late. It's been 1 year off to find changes in consumption, right? So
Right.
in this case, they deploy an anomaly detection system with very cheap and efficient sensors that they install to the HVAC and water systems. And they created systems that align some stores that they use as a pilot, and they were able to reduce water usage up to 40% just over a week. Not by necessarily making retrofits, just making adjustments on how things were utilized. So this doesn't just alert, but it gives you context, right? Things like weather, service logs, occupancy. And it really shows you how when we change this mindset, right, of tracking 1 year later versus let's actively do it, we can actually gain efficiency and we can still report. So in this specific deployment from the retailer from a taste caddy, they were able to reduce HVAC energy consumption by 12%. They were able to detect 42 equipment failures in advance, not a year
Oh,
later, because they were
predictive.
tracking the information like that. And they saved over 3.2 million just with a pilot, right? So that's an example of how you can use AI already with techniques that have been here for a while. It's just we didn't get the fancy AI point of view, but that's an example that change. And then around the supply chain, which I know that's a topic that is very close to you and you're interested. So scope 3 is the nightmare data for everyone, right? Because it's fragmented, it's unextracted. If you get the opportunity actually to ever get it,
It's usually inferred rather than measured.
correct. And if they even respond to you, because again, it's not like they don't want to respond. I know
Sure.
because of experience, like they get bombarded by the same request by multiple companies, and because there's no regulatory requirement, they will simply ignore it, right? But you get invoices, PDFs, right? Different languages, right? Inconsistent supplier reporting. So what AI can turn is this messy sustainability supply chain data that actually you can use. So the typical workflow will be ingest that spend data, classify the purchases, evaluate my sustainability criteria against these contractors' standards for sustainability, attach emission factors, track the suppliers. So it was really small in that end. But then what you can do is actually start asking some questions. If we shift 20% of our steel spend to a supplier using electric arc furnaces to this other supplier, you can ask those questions in advance. What would be the impact? And that
Absolutely.
kind of a scenario analysis completely changed the mindset. But the reality is that the industry is it's my complete mindset. So this is kind of like paradigm shift we need to make in the industry to start thinking in these terms, right? And not being so worried with reporting, because if you do these, you're actually gonna make reporting more efficiency while you gain operational efficiency and save money as part of the process, right?
And
So this point is crucial, and to point that to wrap up with this case of scope 3, because if we target the top 10 to 20% of suppliers where more emissions sit, and this is according to a recent McKinsey study, this can estimate to help us reduce 15 to 20% of scope 3 emission reduction in a short time frame. So only by tackling, identifying with the data where the top suppliers and applying some of these techniques, we can have a huge impact on scope 3.
right, and we actually thank you for mentioning, but we actually looking at the way to unify these reports. We calling the sustainability transaction standard. We are working to create a working group where we can figure out before even we start to look at the data transmission and these elements that AI can measure. We starting to look at how the humans have to reconfigure their relationships in the supply chain in order to create the structures, right? The legal structures, the contractual structures, to initiate the data transmission and have it homogeneous across the supply chain. Because as you mentioned right now, and by the way, reporting should be an artifact of data collection and not the main scope of doing these projects that you mentioned. So real
Correct.
time, near real time. So once you have the data, sure, it's really easy for AI in a couple of minutes, hours to create whatever reports you want in whatever formats you want, according to whatever standards. But you also mentioned something else, and I think it's important. As you are going through, I realized that the financial industry started to see ESG as a label for, investment stocks and ETFs. But eventually, financial industry woke up to the fact that sustainability is a critical element of the financial health, of the resilience, if you want, of the companies. And one other part which you observe now is the insurance, which is part of the insurance industry, which is part of financial industry, are starting to look really carefully at the risk. And we see it even not only in the commercial real estate, but also in the consumer real estate, in the private real estate. We see the insurance insurance fees going up because of the sustainability factor being considered in. As you said, if your home is on the floodplain, and that floodplain, which is labeled 100 years and had 3 floods in the last 10 years, the AI will signal it and will result in a very different way we approach building new structures and selling real estate, private real estate.
Correct.
So can we go a little bit more technical and on the models training and audit trails, as this is another part of the considerations we have to give to AI?
Yeah, correct. And this is going back to this. I'm going back to this diagram that I was showing a couple of minutes ago. Let me know if you can see it on my screen, please.
It's coming up, I think. Yes.
Yeah, perfect. So when we look at AI, of course, right now the discussions, if you see in the media and everything, it's centered around this component here, frontier model labs, which is your Gemini with Google, Claude with Anthropic, right? And of course, OpenAI with ChatGPT and the different services they provide and the different agreements that they're doing and the build that is behind that, like the demand for chips, processors, that's driving the need for NVIDIA or Oracle being involved in this deal. So we're creating this huge architecture for these, right? And the reality of what this component of AI is a subdomain, which is the large language models. Of course, some of these companies, including Google primarily, have done AI for several years, and it's not all the only AI they've done. It's just only the commercialized one because you can chat with it. You can talk with it in natural language, which make it more accessible. But if you start to think in terms of the scale, like how the GPU intensive, meaning the computation that you need to do in order to use it, and then how water and energy intensity is from the usage, but also the process of training these models that requires that computation consistently running. It's like every time that you see that GPT-5 and Opus 4.6 coming out, that means that for a time frame that it's getting shortened, by the way, right? But by a time frame of 3 to 6 months, it was probably a year, you're using the full capacity of those data centers to run those computations to give birth of a new baby, which is a consolidated model that have processed all these different data points that it's ingesting, right? And it's like literally taking all the internet, more corpus of information. And that's why you see investments, including other companies like XAI from Tesla regarding Elon Musk, is that they're building these huge data centers to be able to give birth a new model every time with super capacity, which they are mean is what we call this concept that you might have heard before, which is this general artificial intelligence and then AGI, right? Like the AGI, absolute, like one AI that is capable to do it all. But the reality of things is that these models are pushing those, they're called frontier models, they're pushing those frontiers to be better and better every time. But there's a lot of components here in terms of the demand that it creates, the build out to be able to create these models. How these models were structured, and this is more from computer science, is when you created neural networks and you created to create these large language models, what the creation of this was trying to model how the human brain works. And you know, the human brain is a connection of millions of neurons interconnected that can help us come up with ideas. And we were able to land into the moon without AI in the past, right? What this infrastructure we're building is trying to replicate that. But the difference between the human brain, which has been the most intelligent artifact in this planet, it runs only with 20 watts, right? And it's able to produce all these computations, and then we can all collaborate and interconnect. This deployment here with these models is the best that we can do with the existing technical capabilities, right? Is projecting to the future that because of the scale, we need to build a lot of data centers. Because of how the current training techniques work, is we need to push to the limit and consume more. And we're not planning necessarily on being more efficient in the way we do it. And this is where this challenge that not only is happening in the United States, and the competition between companies, but what is happening against China, it makes it very interesting. So in China, you know, there's been a limitation on the number of chips that they can have, advanced chips to do their training. So they have become a little more resourceful. How I can get, considering my constraints, how I can get more creative to push more of this old model of a GPU to get even a harder frontier. And I think that's something that last year with this whole DeepSeek moment, the industry learned, and they're trying to push for that. But that effort, right? They're in a race. They're trying to build out. And right now, the only way to imitate the human brain is to build big and at scale and having full production. But we need to increase that effort to make it more efficient, right? So talking specifically, going technically into how this is created, is that there are two different costs of AI. The first is the training, which is the upfront computational cost, very expensive. All the resources are put there. So every time there's a new announcement, everybody say, "Oh, this is a new frontier. We're ready at AGI." You see it across the news,
And
right?
Alejandro, when you refer to training, maybe we should mention also the human factor, right? All these
Correct.
20 watts brains, they have to work with AI with the baby AI, if you want to give it personality and knowledge.
Correct. So first, it occurs all the ingestion of data, right? It's literally giving this a lot of information is processing, right? And it opens its size, right? It's like when you have when we're having a human, you think that human doesn't have information, but it's at the genetic level, there's already a lot of information, right? That has processed information, and then you have the environment, but then you start training it to model in such a way. And that's the reinforced learning part of the models, which takes some time. You need, and there's a lot of ethics criteria, but then testing to make sure that the model that you're going to put out is not going to be a danger for the world, right? But typically, going back to the point of the costs, right? The real cost can be like training a frontier model, right? Every set of training for a new model, because you know a company like GPT or others can have multiple running, can take between 300,000, 500,000 liters of water, right? It can spend a lot of money as well. And a lot of this is in terms of how we are going to be, what's going to be happening. So the projection is actually that by 2028, right, only by we will be spending around 1 trillion liters of water just on training these models. And when I say water, is because of the cooling system you will require, so that you can have the processors running and everything, right? So the projections are very big, right? So and then when you use it, there's also costs related to that, right? And water usage. So for example, Gemini recently, and this is where a lot of the frontier labs are not sharing necessarily information. It can come from estimates, but Google published that their own methodology for estimating Gemini usage for a text prompt, a simple text prompt. When you ask, imagine not something very complicated, something you write to it. It can use about 0.24 watts of hours of energy. It can emit 0.3 grams of CO2 equivalent, and it can consume 0.26 milliliters of water. So it's like 5 drops of water, right? Which think, oh, it's tiny. What is my impact? But if you multiply it by the billions and billions of prompts, and then a prompt could be multiplied, like, I mean, it gets bigger,
Mm-hmm.
that scales, right? That's where you really see this scaling. And this open up the question in terms of, again, the frontier models will keep pushing that. The current build out design is the best that we can currently do to do it, to deploy these models out of the world. But the question is, uh, the right sizing from the consumer point of view, not only as an individual user of these systems, but also companies. It's where you decide to use a certain model versus another. When you decide to use an open access model that can run in
Right.
your computer versus running on this on the cloud basis that will utilize capacity from all these different data centers, when I can decide to use a certain thing. And since I have a 2 years and a half child right now, that I mean, when I learned before she was born that ChatGPT and all these things was happening, and I envision a world in which, because AI is essentially infrastructure and it's a usage, the same way we say turn off the light after you leave in that room or close that sink of water, it's how we can think on AI and tokens by, hey, let's be responsible in our usage, because that's ultimately going to have an impact on the grid. And also how people that are designing these tools, right, when they're creating a new model or when you're already deploying it, we can make the decision on how to make it as efficient as possible, right? So one example of the work is that Google itself is already trying to find ways in which they can operationalize and make efficiency, right? And they shown that depending on where they decide to execute their in their different data centers, the requests from Gemini, depending on where they place the capacity on a given time, given considering factors like energy demand or grid capacity or water capacity, they can have a huge impact just by simply saying, from this time to this time in the day, where I'm going to be running my models from,
Sure.
which data centers I'm pulling for information. And that can have already a 33x reduction in energy. Because if you're pulling from data centers that are in a really constrained time in the day in a region like Virginia, that already is
Right.
a grid capacity, it's going to be more expensive. You're going to emit more, right? And you're going to ultimately spend more, right, by executing this information from the models. And it's not new. It's not news that all these companies, except for Google, that has been around for several years, that are in the space of AI, are not making any money right now. They're not making revenues. They're getting a lot of investments, but they're not really making money out of this. They're trying to push forward to achieve this concept of AGI. But at some point, this race will stop. There won't be enough resources coming in. And that's when they will start asking themselves, okay, I'll either raise the price of $20 per month for each of these products to reasonably, to be honest, this should cost 150, because otherwise I cannot keep up on my own. That's when
Yep.
you're gonna be seeing more and more impacts. My hope is that these questions are asked in advance, and then we have more and more of these companies trying to be more smart in how they use these systems.
Uh, very, very broad and very deep in the same time analysis. And thank you for bringing the learning models and the AI training. Now, a question is, okay, so these data centers are used for training, but they are used also for dialogue with people, right? For interaction with for delivering the service to the consumer, right? Uh, are there any metrics which show the percentage of usage for training versus usage for delivery of the AI? Let's call it the service.
So there's not really much metrics other than we can hope what some companies to do. When we're doing the training phase, you're really dependent on estimating the estimating like the capacity of the model, like what is the size of the data center, how long it lasted. The only true way to do it is actually by getting these companies disclosing that information, but there's currently no regulatory requirement for that. When we're talking already at the deployment, that's not, it's not, I'm saying it's easier, but you can actually estimate, like the estimate that Gemini came out with. So there's some form of methodologies. So you have some very interesting initiative and people out there working on the environmental impact of AI stage that they're and very good initiatives coming from initiatives like Hugging Face, which is this open access AI initiative that we can talk more in a moment about the open access world, which is going to be super important thing in the future and is already becoming more relevant. But how they can come up with some of the methodologies to come up of some of the estimates are around there, right? But these estimates that I'm giving you is just projections, looking at the current build out of data centers, the future build out, and knowing what these data centers are used for. Because something that only few people understand, unless you're between the industry, is that the data centers that were existent 2 years ago are completely different than the data centers we have today. 2 years ago, 2 years and a half ago, all data centers were doing was hosting cloud data, right?
Right.
For your AWS, Google, and other, and all your services. So, I mean, it consumes energy, but it's not the huge sponge that is out there consuming a lot of resources, because now you're doing training, now you're doing very intensive computation, which is a complete different game, right? And also the scale of the data centers is different, the energy that is put into that.
Right. No, and I'm a system architect by training, so I know the structure of the data center changed completely since AI, the hyperscaler, had been introduced. Is not the same architecture. One tidbit is like we're running out of space of cabling, because the standards are for cabling data centers, not hyperscalers. So the level of interconnection between the GPUs is few orders of magnitudes higher, as an example. But I would like to reserve more questions for next time. But I have one final question for today, Alejandro, and this is the question about the skills gap in AI. How do you see them? Well, maybe without loading, is there a skills gap in AI right now in for sustainability?
Yes, and let me share this. This is going to be especially useful for recent graduates and then people in the space of sustainability that want to see this space. And the reality of things is that the industry, I mean, a lot of individuals feel challenged by this, right? Like, hey, what is this going to happen? I see it constantly with computer science graduates, for example, right? Or
Right.
recent people joining the finance industry and consulting. So while it's presented challenges, it's also open up opportunities, right? The problem is that if we assume we're going to be destined to do the work that we were taught in university to do, and we're going to be crunching data as an analyst, that's not really a differentiator. What the practical answer is that there's opportunities, and there's several set of opportunities. And one of those is the industry needs translators, someone that can translate these challenges that I presented in terms of where we build AI, which data centers, where's the best location to do it, what model I can use, what questions do I need this type of AI or this type of AI versus the model? Can I use open access versus others? We need sustainability team experts to understand that and being able to communicate with the technical teams, right? So while they can speak about risk, materiality, emissions, the technical team will talk about tokens, data pipelines, model selections, latency. That translators that can communicate that and turn that into business decision is definitely going to be a very important skill. The second one is, as I tell some of the interns that work for my company, helping build Seabridge AI as well. and they've been gaining all this experience that unfortunately they're not able to gain in class. They are learning more about AI agents. And one of the things is that in the future, you'll have intern or an analyst themselves be manager of multiple AIs. Because as long as we can do this automation of AI tasks, you will always need oversight. So people, and this is go beyond just sustainability, but that can truly become managers of AI and reinforcement learning. That's going to open up a lot of possibilities. And what you see here, it's just a list that I created on some opportunities for the space of sustainability. Is you will have new roles or already in demand on AI infrastructure seeding strategy. Where do I place these? GIS analysis, grid analysis, water risk assessments, right? Community engagement, industrial
Excellent.
AI optimization, right? Which is all these things on what we were discussing. We're going from the auto model of collecting data every year to automatically collecting data, doing time series analysis, predictive analysis. That's new opportunities. Energy system flexibility architect. So like the example of Google, where do I run this in a given time by analyzing grid operations, API optimization, and others. Nature tech, that's a growing space. Like the example I provided from this in Brazil from these sensors, like AI power conservation skills, that's all going to be very in demand. And climate, specifically about hard tech and materials, like people that are from material sciences, it's life cycle analysis, material sciences to improve these. And then all the governance and policy part, right? Internally in the organization, how you can set up your targets, but also with new companies. And at the end, the three principles across all these opportunities is one, you have to be the bridge or the translator between tech and sustainability teams and your business. Second, system boundaries in designing systems. You have to ask where impacts start and when they stop. Prevent greenwashing because that's something that certainly isn't destined to occur in the space. And then focus on physical systems. AI is only as relevant, not only, again, if you produce a good report and you save time on that, is how you actually impact the physical world from an energy nature perspective.
Thank you, thank you. And in a previous recent interview, the speaker was the guest was talking about dexterity, ambidexterity, the ability to combine the general and the specific that you. So this bridge of communication you mentioned, for instance, it's very important.
Yes.
I would like
Yes.
to invite you back. If you give me a second, I just want to wrap up and thank you for taking the time today to visit with us. And for our audience to make sure to tune in every week for a new episode of AKFI Actionable Talk series. You'll gain new perspectives on how to mitigate risks and create value by integrating ESG and digital transformation and of course AI, as our guest very insightfully shared his information with us. Thank you again.
Thank you.